This paper was presented at the JCT Traffic Signals Symposium 2023 in Nottingham, thanks to the support of AGD Systems, INRIX, Message Maker Displays, PTV Group, Simplify Systems, Smart Micro UK, and TRL Software.
So I'm James Snowdon. This is my first time at JCT, so I'm really happy to be here presenting our new product, Fusion. We do have a paper accompanying this talk, which is available from our stand in printed format, and that will also be available from the Yunex website soon. Okay, so what I'd like to do to start with is just recap on what we presented of Fusion last year at JCT. And we actually started that presentation with a recap from 2021 as well, because the development of Fusion is something that we've been sharing at JCT throughout, kind of basically showing the progress. So Fusion, as we presented in 2021 in our vision, is a new network adaptive control system, looking at setting the green timings and coordination across a region. And the main vision is to provide optimization for all road users not designed around cars, simple configuration and status monitoring, and also be able to utilize technological improvements to provide performance benefits. So in 2021, we had some simulation results of early algorithms, and these were looking promising. And we're also working in partnership with Transport for London. So we have a living lab set up in London where in 2021, we were just receiving detector data and controlling signals at our first junction. Then moving on to last year, we expanded our living lab to 11 junctions across London, and we continue to expand across London in different areas, different traffic profiles, and we were reporting performance benefits seen on street versus the existing Scoot control systems. But what we're keen to do as we progress and we invest in Fusion is really learn from all of these deployments. So we're really keen to almost like have trials and learn as much as possible from how Fusion is actually performing. So both of these talks are available on YouTube, and obviously I've liked and subscribed to the channel, and I really recommend those for some more information about Fusion and how it actually works. So we finished our talk last year with kind of looking to make Fusion available for customers and looking at how customers can make use of Fusion. So Fusion does not require any new infrastructure. We make use of existing inductive loops in the road. So we were looking to basically look at how Fusion performs on sites outside of London in typical areas. So we were looking at busy regions of typical setups there. So we worked with Hampshire County Council, and they offered us free Scoot regions in Hampshire. We have Aldershot to the north, and then Havant and Fareham in the south. So see some context here as well. So these are busy Scoot regions. So before we undertook this trial, we worked with traffic engineer Craig Cameron from Yunex, who is an experienced Scoot engineer, and he went out and he performed Scoot validation, made some enhancements to the Scoot model, making sure it was quite a challenge for Fusion to be comparing against. Then, for the purposes of this trial, we wanted to basically put Fusion control on these junctions and compare performance using journey time as a service data. So this is data available from here, which Yunex makes available. And this uses GPS probe data. And it's not just in vans, it's basically anonymized data from many different car makes and brands. So these basically give us journey time routes through these regions so that we can get a detailed understanding of how traffic is flowing. Also, just to say, as I present the results, I will be showing demand data. Even though they're journey time routes, this is just demand data at the start of those routes. So it's more for context to get an understanding of which of the busier routes are, and that gives you a bit of insight into how Fusion is actually prioritizing different routes and different approaches. And then the trials were conducted earlier this year, obviously removing bank holidays, the Easter holiday, etc. Okay. So the first region that we'll take a look at is actually the busiest in the trial, St Margaret's roundabout. This consists of 6 junctions around the roundabout, 4 circulating and 2 exit puff-ins. This is very near the M27 motorway. It gets very busy. The tidal flow is from the southeast in the AM and from the northwest in the PM. And Scoot operates here all day. And it's set up with multi-nodes by time of day to help the traffic move across. And also there's some extra controls to help the unsignalized approach from the south and also the approach from the southwest. So we also configured Fusion on these junctions, and there we just put in the fixed offset around the top of the roundabout. And there's some photographs there from a site visit. So these are the journey time routes that we had for St Margaret's roundabout. These were basically chosen as the approaches that they were the main routes that also kind of present the biggest challenge, really, to Scoot control, so the main movements there. So then when we actually look at the journey time performance, what we see here is across a day from 7 AM till 9 PM, average journey times across the length of the trial. And obviously you have Scoot control in orange on all of these and Fusion in blue. And you can see Fusion is comfortably, generally, underneath that line. And I'll dig into some of the details on some of these in a few moments. And you can also see there's demand data on here as well to give you an idea of what those busiest routes is. And it is generally across the A27. So then we can put performance numbers on here, some percentage improvements, and again, sort of telling that story that Fusion is generally giving bigger performance benefits, more journey time decreases to the busier routes. So digging into some of the detail here, my particular favourite result that we see is the evening peak from the northwest, which is the busiest approach in the evening peak. And we see here a huge journey time reduction. I know analysis of delay and trying to quantify delay is quite a science in itself, but if we define delay as anything above the overnight average journey time, this is a 63% reduction in that during the evening peak. So that's quite significant. And then a question we often get asked is how? So basically you can see on the right-hand side comparing average cycle times during the trial. Fusion basically is able to maintain a lower cycle time, so keep the traffic moving around the roundabout, and it makes use of effective offsets as well. So Fusion has an underlying network model, so it's able to really understand the consequences of releasing one queue and how it will then move through the network. And it can, basically it performs very well with kind of emergent offsets, I call them. Obviously, you might have noticed at the start, there is a bit of a negative effect in the AM peak from the approach from the southwest. And I think this is a challenge for any adaptive network traffic control system, that this is essentially a quieter road competing with a dominant stream of traffic from the southeast. And yeah, so that's one challenge. And then I think also here as well, it's not helped by running at a lower cycle time. That fixed offset around the top of the roundabout, when they're actually circulating, they're more likely to encounter red. So this is something that we worked with the traffic engineer to take a look at, and he said that basically Scoot has finer controls over controlling offsets and biasing offsets. And this is something that we're currently working on in Fusion. So we'll be keen to go back to this region and see how it performs with that functionality, which the traffic engineer said would be useful for controlling this. Okay, moving on to the next region. So this is Havant town centre. This is an urban corridor. This is just off the A27 to the south, so it's a very busy road. Basically, the main movement here is north-south. There's 2 junctions to the north and south and a pelican crossing between the 2, and Scoot operates here in the morning and evening peaks only, and during the day it's mover other than that. So the pelican in the middle is just controlled with a fixed offset to the junction to the north to make sure it doesn't fill up that storage space, because it is actually quite close. So again, similar picture, we have our journey time routes through this region, the major routes of interest. And here, as I mentioned, Fusion is only actually competing here during the morning and the evening peak. So it's a similar situation. We have Fusion in blue, Scoot in orange. And you can see here it's a bit of a closer match, but you generally see the performance benefits during the evening peak and on the major routes. And when we take a look at the percentage improvement, that also echoes that as well. One behaviour aspect that we're kind of interested in here in Havant is at this northern junction in the region. Scoot is able to offer multiple demand-dependent stages at the same time so that the controller can respond to local traffic conditions. And this is quite useful when dealing with the right turners here, because basically the actual stage which runs on street depends on where there is demand for the right turn. So it's not as impactful to the main north-south streams. At the time of the trial, we were only able to offer one demand-dependent stage with Fusion and one alternate stage. So yeah, that was a bit of a hindrance for Fusion. But we can still see, even given that we still see very good performance. And actually, that's behavior that we think is more of a hindrance in the AM peak, because during the PM peak under Scoot control, that stage 4, which we had to force in for Fusion, runs all the time. So there is more demand for those right turners in the PM peak. I think there's a KFC and some restaurants just off to the side, and those are more popular in the PM peak. So it makes sense that that's where we see more benefits under Fusion control, because the behavior is more comparable there and it's a bit fairer. So the multiple demand-dependent stages is something that we're currently working on in Fusion as well, but I think it's very encouraging that we see good performance even without that functionality. Then finally, the Aldershot region in north of Hampshire. This is another sort of urban corridor region just off the A331, just to the south of Farnborough and the A3. This has 4 junctions, and Scoot operates here all day. And again, similar picture with journey time routes. And then when we look at the demand, I think here it's a bit more close as well. And then we do see some benefits in the peaks on some of the approaches. So here the feedback from the traffic engineers was that Fusion does do a good job again with the offsets, because these junctions are all quite close together, and actually progressing traffic through the regions, which it's able to do well. So we see an overall improvement here as well. So I think the overall message from this trial is that we're absolutely delighted with Fusion's behavior across all 3 of the regions. We were able to see journey time improvement under Fusion control, and we were able to learn kind of areas for development which we're currently working on, and be able to look at the impact that that actually has. So ourselves and Hampshire were very happy with the outcomes of this trial. And then just some final feedback points here. Fusion, as we hoped and as we said under the vision, is seen to be simple to set up. The UI is quite straightforward, and it only requires a basic knowledge of traffic terminology to use. Then also the good decisions with little input. Kind of as I mentioned, like in Fusion, there aren't too many levers at the moment. There's link biases and fixed offsets, but a lot of it is that the optimizer is able to be left to make these good decisions, and they last throughout the day. Then we have seen as well that Fusion generally prioritizes the busiest approach, which is something else that we look for and see as being a benefit. And then another learning was to do with the weights and biases. So especially transferring sites from Scoot to Fusion, we did find that the optimizer works in a different way, and some of the weights and biases used under Scoot control don't directly translate into Fusion. So we are building up the evidence of how to configure Fusion and how the sensitivities on the weights and biases, and we were able to make use of some of that knowledge from London in this trial. But yeah, that's something that we're developing as more and more regions are controlled by Fusion. Okay, so just to take a look at the context and the Fusion roadmap, Fusion is currently in a position where we are making offers to customers now. Really happy with this output that we've seen in Hampshire. I haven't really spoken too much about Fusion functionality, but we're able to offer priority now as well for public transport. We have got the intuitive UI that we've shown in previous years. So that's the current offering. And then on the roadmap, as we continue to invest in Fusion, we're able to offer SPAT information, looking to really make it even easier to configure and import a lot of the configuration items automatically. And then things like network enhancements, so being able to model flares even better, and advanced detection, looking at other data sources that might make use of new detection technologies. So I think it's quite an exciting roadmap, and as I say, as we make Fusion available, we'll continue to invest in it, and I think it's going to be a really exciting journey. So that's it for my talk. Thank you very much.
Just while I let people have a think of questions, one that I go back right to when I first fell into this industry back in 2000 and was working on radio traffic news and going to authorities and saying, if you make it, you know, if you tell us we can reduce the traffic in a certain place. And the feedback I would often get from quite negative, dyed-in-the-wall people was, well, if we make it better, then all that will happen is more cars will come out on the road. Have you seen any evidence that you've improved things and you've got this sort of 8-9% improvement, and then actually it started to creep back because you've seen more traffic because the journey time has reduced and people think, oh, I'll go that way now?
Yeah, I think that's an interesting one. I mean, the short answer is that's not something we looked at because the trial was only over the course of a few weeks earlier this year. But yeah, you're absolutely right. Like, obviously there is a feedback mechanism where if you improve the journey times on one route, more people will use it, and then it takes a while for traffic to balance out and reach an equilibrium. But yeah, I think that would need kind of longer term studies with Fusion.
Okay, right, I've got another question, but let's go for the audience, please. Start with Darren Capes, please, if we can get a mic over to Darren.
Thanks, Paul. Darren Capes, Department for Transport. I was really interesting, James. Really good stuff there, interesting to see. Have you done any economic analysis of Fusion in terms of installation cost versus scoot or operating costs? Have you developed any kind of benefit to cost ratio work yet around this?
Yeah, so to be honest, we haven't done too much of that yet. But as I said, Fusion makes use of the current infrastructure, so it doesn't require any infrastructure changes. So it is just kind of the ongoing support costs and the hosted system. But yeah, we haven't really looked into that in detail yet.
And a similar question, have you done any work on turning the benefits you've seen in terms of journey time into wider cost-benefit figures?
Yeah.
You've done some work on that yet, or is that still to do?
No, that's also still to do. But like I say, we're starting to quantify those journey time benefits. And yeah, looking at things like value of time is certainly on the list of things to do. And I certainly expect to see that.
Thank you.
Thank you.
Mark Playdell over there, please.
Thank you, James. The Havant site had a ped crossing in it. Given the interest in active travel that we see, have you got or will you be getting any data about the impact you've had on pedestrian movement through that little bit of the network as well?
Yeah.
And of course anywhere else on the network where you've got peds.
Yeah. So pedestrian movements is something that we've looked at more in simulation, to be honest. And that's where we found that generally decreasing the cycle time in the way that Fusion is able to decreases the assumed wait time for pedestrians. But yeah, I expect that we will be doing further studies on the actual impact of active road users. And also, I think there's extra forms of detection which we can bring into Fusion. Like, Fusion is very set up for multimodal detection, like it considers objects in the network. So I think if we're able to make use of pedestrian detectors, like volumetric detectors, that will be even more beneficial for us. But like I say, in simulation, we do see, because of the reduced cycle time, assumed benefits for pedestrians.
Thank you.
Any more questions? Okay, one over there from Jackie, please.
Thanks. Jackie Davis, Bath and North East Somerset Council. I've been following this with interest, and it's good to see quite an honest, set of results and quite a robust scientific process followed. So thank you for that. But one thing I did pick up on, your links that you used for measuring journey time, some of them looked rather short. Having worked in Bristol for a while, those would have been just the queue lengths that some of my clients in Bristol. So how certain are you that you captured not just the current queue length, which didn't really change because the impact was beyond the end of that.
Yeah.
Did you make sure that you were going beyond the end of the current queue?
Yeah. I mean, I think that's particularly true of the approach from the west in Havant, which is actually the exit from a retail park, which is a small stretch of road. And yeah, I think, to be honest, this is the first of many case studies with Fusion. So there were reports from on site, especially with that shorter link in Havant, that the queue wasn't backing up back into the retail park. But yeah, I completely agree with you, and I think in future we will look to have routes of different lengths, but at least in terms of site visits, the queues weren't backing up beyond those routes.
Excellent. The other comment I wanted to make was just a thought about the revalidation exercise you did in advance. We all are aware of the state of many of our junctions in terms of their validation quality. And it would be interesting, in addition to the improvements you got from going from Scoot to Fusion, to see the improvements you got going from an unvalidated or having been a while to what we were able to achieve there, because that is the sort of thing where we can get people to come in and do validation exercises for us in our council areas, and we can quantify those benefits in the manner that Darren was just mentioning.
Yeah,
so that
certainly
would have been interesting to see as well.
Yeah, okay, thank you.
Okay, we're out of time, but remember, Yunex, huge supporters of the symposium. They have a stand outside in the exhibition. We have plenty of time during the lunch and coffee breaks and so forth. So if you've got any more questions, go and speak to the Yunex guys on their stand outside. But for now, huge round of applause, please, for James Snowdon.
Thank you.